So today we're going to talk about graphing a quadratic equation and finding solutions of a quadratic equation, specifically finding them when we look at a graph. So we are going to be using a table of values to graph our quadratic equation today. And our only vocab word of this objective is the word parabola, and it looks like parabola, but that's incorrect. It's parabola, which is what we call the graph of a quadratic function. So the graph of a linear function we call a line. The graph of a quadratic function is a parabola. So it's just how we describe the shape of the graph. So our first example, they want us to use a table of values to graph this quadratic. We know that it's a quadratic because the highest exponent is 2, and it is already in standard form, so we can begin graphing. So our key point of this example is how to use a table of values to help us graph. So the first step is going to be to create your table of values. Okay, so this is done fairly easily. It's a little more complex than a t-chart. So we make spots for our x's and spot for our y's, and then we leave this space in the middle, and that's where our rule goes. And our rule is actually going to be the function that we're given. So we are going to create our table. Okay. Step 2 is choose your inputs. Choose the domain, right, or your x's. So you can really choose any inputs that you want in a table of values. We are going to encourage you to use 2 positive values, 2 negative values, and the number 0. And you can choose any numbers that you want. So I would say stay pretty close to 0. You don't want to choose negative 100 because the answer will probably be way off the graph. But I'm going to choose negative 3, negative 1, 0, positive 1, and positive 3. So I have 2 negatives, 2 positives, and then my 0. Okay. Step 3 is that I need to substitute my x's into the rule. Alright, so wherever I see an x in my equation, I'm going to substitute the x that I've chosen. So I have negative 3 squared minus negative 3 minus 6. I have negative 1 squared minus negative 1 minus 6, 0 squared minus 0 minus 6, 1 squared minus 1 minus 6, and 3 squared minus 3 minus 6. And if you spread this out a little bit more on your paper, you can also do your work. I can do the work very small underneath because, to be honest, if I did this all in my head, I would probably make a mistake. So it's going to be helpful to show some work. Another thing that you need to remember, and before we were saying common errors, but we're going to change that a little bit to a QT, right? A quick tip. A quick tip is that you should use parentheses when substituting. Right, especially when substituting, because here we have these negatives squared, we have minus a negative. If we forget our parentheses, when we substitute our numbers in for x, it's going to be very easy for us to make sign mistakes. So not only use it when substituting, but also when typing in calculator. So if you put all of this row into the calculator, you have to be really careful about using your parentheses. Some calculators will not recognize order of operations, and they'll give you a different answer if you're not using the parentheses correctly. So we can go back. Negative 3 times negative 3 is 9. Minus a negative is going to be a plus 3 minus 6, which gives us 6, and that is our output, so we can put that in the y column. So negative 1 times negative 1 is positive 1. Negative times negative is a positive 1, minus 6, which is going to give us negative 4 for our output. 0 minus 0 minus 6 is going to give me a negative 6. 1 squared minus 1 minus 6 is going to give me a negative 6. And 3 squared is 9 minus 3 minus 6 is going to give me 0. So from this, I get ordered pairs. So if you would like to draw another column, just so that you can write your ordered pairs, that would be an extra thing that you could do to really organize your table. So then your ordered pair is going to be input, output. What you plugged in, what you got out, what you plugged in, what you got out, what you plugged in, what you got out, and your last point. And so once we get step 4, which is get ordered pairs, we can begin to graph, which is really the whole point. We're trying to graph using a table of values. So far we've done all of the work we needed to help us get to the graph. The final step is plot your points on the graph. So if you want to draw this below the table of values in your notes, that's fine. I'm going to move to the next page with the graph paper. So I have the points already written down that I had gotten from my table of values, and now we're going to graph. So I'm going to plot my negative 3, 1, 2, 3, 4, 5, 6, my negative 1, 1, 2, 3, 4, 0, negative 6, 1, negative 6, and 3, 1, 2, 3, 0. So it's kind of hard to see what I have going on here, but once we know what a parabola is supposed to look like, then this will be much more of a guide. So a parabola is actually a nice curving U shape, which is kind of difficult to draw, but there we go. It's not a V. We want to make sure that this is a nice curve at the bottom, not a point. Right? So it curves and then goes up, it curves and then goes up. So our parabola will always look like a U. So you plot your points to get the general idea of what that U is going to look like. And here we have our graph. So to find solutions from a graph. Once you've found your graph, fantastic, but what's the point of graphing? It's because we want to find the solutions. So I graph. Step 1 is circle where the parabola crosses the x-axis. Alright, so I want to look for where my graph, so here's my parabola, this is my x-axis, and I circle right there, and then going back up, I can circle right there. So that's step one of finding the solution. Then second step is you're done. All right. Look at what number that x is on, and your solution is going to be x equals whatever number you circled, so wherever it's being crossed. So in this example, my circle and where my line is crossing is at -2. So my solution is going to be x equals -2. And over here, where I circled is 1, 2, 3. So my other solution is going to be x equals +3. And those are my two solutions for this quadratic. So we use the table of values. You plot the points. As long as you plot carefully and you draw your curve according to the points you plotted, it should cross, and that's how you find your solutions. So let's think back to what we've already learned about discriminant. If I have x equals 2 as a solution and x equals 3 as a solution, that means I have two solutions because I have two different x values. So if we think back to when we calculated a discriminant, how did we get two solutions? Well, let's think back to that table that we made for our discriminant. So the first part we had was that a b squared minus 4ac, which is our discriminant, if that came up positive, then we had two real solutions. And we just learned what that looks like on a graph. That means that our parabola is curving and crossing in two places. So any graph that crosses in two places is going to have two solutions. Now we can also have parabolas that turn upside down, right? But they're going to cross in two places. That's okay. Not every parabola is going to open up. Then the second case we had was a b squared minus 4ac that was 0. And we've already learned that this means that there is one real solution. So what is that going to look like on a graph? How are we going to find one solution if our parabola is crossing in two places? Well, if the parabola kind of moves up a little bit, it's just going to touch in one place. It just kind of touches and then goes right back up. So it's only going to cross at exactly one spot. That's how we get our one real solution. And again, this could be a negative example where the parabola comes up, touches, and then just goes right back down. And again, that's an example of one solution. And then the final case was if our b squared minus 4ac was a negative. And we learned that that meant we had no real solutions. And this would make our graph keep going up. So here it was crossing twice. Here it's just touching the once. A no solution is just going to go down and up, and it's not going to cross the x at all. And for our negative example, it would have maybe a parabola that just goes up and down and just doesn't cross over. Alright, so the important thing here, our quick tip here, is to remember that the discriminant which was our b squared minus 4ac, right, gives the number of solutions. Alright, the number. So the discriminant tells us whether there's 2, 1, or none, while the graph shows what those solutions are. So if in your notes you want to get out a highlighter and highlight your quick tips so that they stand out, that would be a really great idea. So here would be a quick tip. Alright, so let's see what these look like as examples. So here we have example 2 and example 3. They want us to find the solutions. So to find the solution of a graph, we said step 1 was circle where the line crosses the x-axis. So here's my x-axis. Circle where it's crossing. Alright. So here I can see it's just that case where it comes down, touches, and goes right back up. So there's only one solution. So very often people will write 1, 2, 3, 4, 5, and they'll say, oh, the solution is -5. But just leaving this as -5 would be incorrect. In order for it to be a true solution, we need to write an x equals. Right? So it has to have an x equals. So there's another quick tip. Solutions must be written as an x equals whatever your solution is. So again, if you need to highlight that so that when you're looking back in your notes that really stands out, and then you won't make that mistake. Alright, so over here, example 3, again, the first step was to circle where the parabola crossed your x-axis. So there we see our 2 points. It is an upside down parabola, but that doesn't change our solutions. So I want to count and see, alright, I have a solution at -1. So again, looking at my quick tip, I know it has to be an x equals -1. And then I have a 1, 2, 3, 4, and an x equals -4. So those are my 2 solutions. So that's it. Here are 3 more examples. This is your self-check for this video lesson. We have 3 graphs. If you just do a quick sketch of the 3 graphs in your notes and then identify or find the solutions for each graph. So find the solutions in graph 1, graph 2, and graph 3. Alright, make sure you come back to class with any questions.